Every substance is associated with some magnetic character. The magnetic property of a substance is due to the presence of electrons. Each electron in an atom is regarded a micromagnet. The magnetic moment of an electron originates from two types of motions, known as spin-angular motion and orbital angular motion. Thus, every electron has a permanent spin magnetic moment and an orbital magnetic moment associated with it. The values of magnetic moment are very small and are measured in units called Bohr magneton. 1 Bohr magneton is equal to 9.27 into 10 to the power minus 24 ampere meter square. Based on magnetic properties of materials, they are classified into 5 categories, namely diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic, and ferrimagnetic. Let's discuss the properties of these materials, starting with diamagnetic materials. Diamagnetic materials are materials that are repelled by magnets. When a bar of diamagnetic material is placed in a non-uniform external magnetic field, it tends to move from a region of strong magnetic field to a region of weaker magnetic field. Diamagnetism is shown by substances in which all the electrons are paired and there are no unpaired electrons. Although diamagnetism is present in all materials, its effect is very weak in most of them. Some examples of diamagnetic substances are water, sodium chloride, and benzene. Let's look at paramagnetic materials. Paramagnetic materials are materials that are weakly attracted by magnets. When a bar of paramagnetic material is placed in a non-uniform external magnetic field, it tends to move from a region of weak magnetic field to a region of stronger magnetic field. Paramagnetism is due to the presence of one or more unpaired electrons, which are attracted by the magnetic field. Some examples of paramagnetic materials are iron +3, copper +2, and chromium +3. Let us now discuss ferromagnetic materials. Ferromagnetic materials are materials that are strongly attracted by magnets. When a bar of ferromagnetic material is placed in a non-uniform external magnetic field, it has a strong tendency to move from a region of weak magnetic field to a region of stronger magnetic field. In solid state, the metal ions of ferromagnetic substances are grouped together into small regions called domains. Thus, each domain acts as a tiny magnet. When the ferromagnetic substance is placed in a magnetic field, all the domains get oriented in the direction of the magnetic field. Iron, cobalt, nickel, and gadolinium are some examples of ferromagnetic materials. Let's now discuss antiferromagnetic substances. These substances have the same domain structure as ferromagnetic substances. However, their domains are oppositely oriented and cancel out each other's magnetic moments. Manganese dioxide is an example of an antiferromagnetic substance. Finally, let's look at ferrimagnetic materials. Ferrimagnetism is observed when the magnetic moments of the domains in a substance are aligned in parallel and anti-parallel directions in unequal numbers. These substances are attracted more weakly by a magnetic field as compared to ferromagnetic substances. Magnetite and ferrites like MgFe2O4 and ZnFe2O4 are some substances that show ferrimagnetism.